Hi everybody, my name is Kate Berry from the University of Texas at Austin, and today I'm going to talk to you about Pirate Math Equation Quest. Specifically, I'm going to talk to you about equal groups problems. Equal groups problems are one of the schemas that are featured in two of our interventions. Our small group intervention with total difference, change, and equal group schemas, and our third grade STAR test prep intervention with total difference, change, and equal group schemas. Every intervention follows the same 5 components. We have Math Fact flashcards, Equation Quest, Buccaneer problems, ship-shape sorting, and our Jolly Roger review. We primarily talk about equal groups problems during our Buccaneer problems and our Jolly Roger review. During our Buccaneer problems, students solve equal groups word problems, and that is a guided practice activity with the teacher. And our Jolly Roger review, students solve equal groups problems as an independent practice activity. However, we primarily discuss equal groups problems during the Buccaneer problems. So today we're going to focus on equal groups problems within our Buccaneer problems for the focus of this video. You will need the following 4 items when you are solving equal groups problems with students. The first is our Run poster. This is our word problem attack strategy poster that we use for any word problem we see. Next, you'll need your equal groups poster that students follow these steps to solve the problem. Third, you'll need your Buccaneer problem worksheet. And fourth, you'll need a pencil. Now, as students start to become familiar and fluent in solving equal groups problems, the teacher may choose to fade out the Run in equal groups poster. For the purpose of this video, however, we will use all 4 materials. So in our Pirate Math Equation Quest intervention, we introduce students to 4 different types of word problem schemas: total, difference, change, and equal groups. We teach students to understand word problems as belonging to a specific problem type, and then using the schema steps attached or aligned to that problem type to solve the problem. The focus of this video is equal groups. Now, whenever we solve word problems with students, we always teach them a gesture. For each of those 4 schemas, total, difference, change, and equal groups, students learn a corresponding gesture. This gesture helps them recall what the schema is talking about. For equal groups, we teach students that we have groups with an equal number in each group. We identify this gesture by putting our palm out to show the groups, and then almost like we're placing an object in our palm to show the number in each groups. So if I were going to do the equal groups gesture, it would look like this. We have groups with an equal number in each group. Anytime students solve an equal groups problem, the student and the teacher will be gesturing using this gesture. We have groups with an equal number in each group. Now, today we're going to talk about 3 different types of equal groups problems that students encounter when they solve Buccaneer problems. We have problems where the product is missing, the number in each group is missing, and we also have an area problem, which is also an equal groups problem. So in this video, I'm going to demonstrate how to solve a problem where the product is missing, where the number in each group is missing, and an area problem. Before we solve that, let's take a look at our equal groups poster. We use the equal groups poster when we're solving any equal groups problem. The first step says write GR times N is the same as or equals P. The GR stands for the groups, the N stands for the number in each group, and the P stands for the product. So students will first write the equal groups equation. Step 2 is find P, or the product. Step 3 is find GR and N, which means we're finding the groups, and then we're finding the number in each group. Step 4 is write the signs. In an equal groups problem, the signs are always times and the same as or times and equal. Step 5 is to find X. And then at the end, we have our little parrot here who's going to ask us, does our answer make sense? So let's first look at a problem where the product is missing. Whenever we see a word problem, we teach students to run through the problem. Run is the word problem attack strategy that we use for every word problem. It doesn't matter which attack strategy you use, as long as you're implementing the same attack strategy for every word problem, and as long as the attack strategy involves students reading the problem. So before we run through the problem, we need to check to see if there's a table or a graph. Here I look, there is not a table or a graph. If there were a table or a graph, I would number it before running through the problem. But there's not a table or a graph, so I can run through the problem. To remind me of the run steps, I'm going to write an R, a U, and an N. The R stands for read the problem. Let's read the problem. It says Sophia's family eats 2 sugar cookies and 3 chocolate chip cookies every day. How many sugar cookies does her family eat in 10 days? So I've read the problem. I can check the R off. The U stands for underline the label and cross out irrelevant information. I look for my label in this question sentence, which is a sentence with the capital letter and the question mark. The question is asking how many sugar cookies does her family eat in 10 days. The question is asking me about sugar cookies, so I'm going to mark that as my label. I'm going to underline sugar cookies. Now I'm not finished with you. I still have to check for irrelevant information. I want to make sure that all of my numbers are talking about my label. We've identified the label as sugar cookies, so we need to make sure every number is talking about sugar cookies. So let's scan our word problem. The first number I see is 2. 2 is about sugar cookies, so I need that. The next number is it says 3. 3 is about chocolate chip cookies. That's about cookies, but I only care about sugar cookies. I don't care about chocolate chip cookies, although they are very yummy. We have 2, we've crossed out 3, let's keep scanning. Our next number is 10. 10 is about days. Days is not about cookies, but we still need this number. If we crossed out 10, we would only have 1 number in our problem. Also, this question is asking us how many sugar cookies she ate in 10 days, so it relates to the sugar cookies, so that information is relevant. Now that I've read the problem, underline the label and cross out irrelevant information, I'm going to name the problem type. When I name the problem type, I need to ask myself, am I putting parts together for a total? Am I comparing 2 amounts for a difference? Do I have a start amount that increases or decreases to a new amount, or do I have groups with an equal number in each group? In this problem, I see that we have 10 days, and for each of the 10 days, we ate 2 sugar cookies. So I know that this problem is about groups with an equal number in each group. To help me remember that this is an equal groups problem, I'm going to write an EG over here to stand for equal groups. Now that I've run through the problem, I'm ready to follow my schema poster steps over here. Step 1 says write GR times N is the same as P. That stands for the groups times the number in each group is the same as our product. So let's go ahead and write that. GR times N is the same as P. Step 2 says find P. Sometimes we know the product, sometimes we don't know the product. Here, we know that we have 10 days and we have 2 sugar cookies for each day. But we don't know how many sugar cookies the family has eaten in 10 days. So I'm going to put an X under the P to identify that that's my missing information. Step 3 is to find GR and N. The groups is how many groups we have. We have 10 days. Those 10 days act as the number of groups. So I'm going to write 10 under GR, and I'm going to cross off that 10 to let me know I've already used that number. We know that for each day, Sophia's family ate 2 sugar cookies. So the number in each group is 2. So I'm going to put a 2 right here. And I'm going to check off that number to let me know I've already used it. Now step 4 is write the signs. Anytime I have an equal groups problem, my signs are always times and the same as. So I'm going to go ahead and do that. Now step 5 is to isolate the X, or find X. When we find X, we teach our students to isolate the X. If you would like more instruction and demonstrations about isolating the X, you can view our Equation Quest video. But for the purposes of today, I'm going to assume that we know how to isolate the X. We draw a line down from the equal sign and we circle the X. The x is already isolated or by itself on this side of the equal sign, so I can just multiply these two numbers. 10 times 2 is 20. So x is the same as 20. Here I have a number answer, but that number gets lonely if it doesn't have a buddy. The number needs a label. When I look back, I see that I have underlined sugar cookies. So I'm going to write sugar cookies as my label. I have my number and my label. The last thing I need to do is check to see if my answer makes sense. If I have 2 sugar cookies on the first day, on the second, on the third, and so on, it does make sense that my answer would be 20. If we're multiplying 2 numbers, it would make sense that my product would be greater than my groups and number in each groups. I'm going to take a minute to erase the board, and then we're going to look at a problem that shows student work, where a student solved a problem where the product was missing in an equal groups problem. So here's an example of student work where the student is solving the equal groups problem where the product is missing. So let's take a look. The student read the problem, underline the label, cross out irrelevant information, name the problem type. Let's look. It says Annabelle gave her 3 sisters and 2 brothers 6 pieces of candy each. How many pieces of candy did Annabelle give her sisters? She underlined the label as pieces of candy. She identified that there were 3 sisters, which we needed that information because she gave the candy to her sisters, but we don't care about 2 brothers. That doesn't have anything to do with the candy or the giving them to her sisters. So we cross out 2 brothers. Now the student named the problem type. We have 6 pieces of candy for each of her sisters. So we know we have groups with an equal number in each group. The student wrote EG to identify that this is an equal groups problem. The student then wrote our equation GR times N is the same as P, which stands for the group times the number in each group is the same as the product. She identified that there are 3 sisters, so 3 groups, and each sister received 6 pieces of candy, which is the number in each group. She correctly solved by multiplying 3 times 6, and we have 18 pieces of candy. We have a number and a label. We know our answer makes sense because when we're multiplying, our product is going to be greater. 18 is greater than 3 and 6. So the student did an excellent job solving this equal groups problem. The second type of equal groups problem that students often see or encounter on the Buccaneer problems is an equal groups problem where the number in each group is missing. So I'm going to take a second to model this. Let's take a look at our problem. Whenever we see a word problem, we need to run through it. This is our attack strategy we use for every word problem. So I first need to check to see if there's a table or a graph. I do not see a table or a graph. If I did see a table or a graph, I would number it. But now I'm going to run through the problem. To help me remember, I'm going to write R, U, N. The R stands for read the problem. Our problem says Stephen has 20 pepper slices to put into 10 tacos. He wants to put the same number of peppers into each taco. How many peppers should Stephen put in each taco? So we've read the problem. The U stands for underline the label and cross out irrelevant information. To find my label, I look in my question sentence, which is the sentence with the capital letter and the question mark. It says, how many peppers should Stephen put into each taco? The question is asking me about peppers, so I'm going to underline my label as peppers. Now I need to check for irrelevant information. I check for irrelevant information by scanning my numbers and making sure they're all about our label. We've identified our label as peppers, so we need to make sure that all of our numbers are talking about peppers. Let's take a look. Our first number says 20 pepper slices. That's about peppers. Our second number says 10 tacos. While 10 tacos is not about peppers, he's putting the peppers in the taco, so we still need that information. Another way to identify whether or not numbers are irrelevant or not, if we got rid of the 10, we would only have one number in our problem and we wouldn't be able to solve it. So we still need that number 10. There are no more numbers in our problem, so we do not have any irrelevant information. So I'm going to cross off the U. The N stands for name the problem type. When I name the problem type, I need to ask myself, am I putting parts together for a total? Am I comparing 2 amounts for a difference? Do I have a start amount that increases or decreases to a new amount? Or do I have groups with an equal number in each group? Here, I have 10 tacos, and I want to put pepper slices into each taco. I know that I have groups with an equal number in each group. So here I'm going to write I'm going to write EG. GR stands for the groups. To identify an equal groups problem, we're going to write EG. Now that I've run through the problem, I'm going to cross off my N, I'm ready to follow my equal groups schema poster. Let's take a look. Step 1 says write GR times N is the same as P. That stands for the groups times the number in each group is the same as the product. Step 2 is find P or the product. Sometimes I know the product, sometimes the product is missing. Here, we know that Stephen has 20 pepper slices altogether, so that is going to be my total or my product. So I'm going to put 20 here. I'm going to cross off the 20 to let me know that I've already used that number. Now, step 3 is find GR and N. GR is the number of groups, and N is the number in each group. I know that I have 10 groups because I have 10 tacos. What I don't know is how many peppers to put in each group. So 10 is my groups because I have 10 tacos. I'm going to check that number off. And N is the number of peppers in each group. It says how many peppers should he put into each taco or into each group. I don't know that information, so I'm going to put an X under the N. Now, an important thing to note when we write the signs, which is step 4, our signs are the times and the same as or times and equal sign. When we have a problem where the number in each group is missing, we're going to have 2 X's next to each other. To differentiate between the 2 X's, we want to make sure to do a little x and to show the time sign, and we want to make sure that the student writes a big X to show the number in each group that's missing. Now I'm going to do the same as sign. Now here, to find X, I can isolate the X, but another thing I can do is ask myself, 10 times what is going to give me 20? I know that 10 times 2 gives me 20, so I'm going to write X is the same as 2. So I have my number answer, but the number is going to get lonely if it doesn't have a label. So I'm going to add my label. Here I've underlined peppers, and peppers is going to be my label. I have my number answer and my label answer. Now I need to check that my answer makes sense. When we have an equal groups problems with the number in each group missing, we still need to make sure that our product is the greatest number. And here 20 is greater than 10 and 2, so I know that my answer makes sense. Now let's take a look at student work. Here's an example of student work where the student solved an equal groups problem where the number in each group was missing. Notice the student wrote R-U-N in the corner. The student read the problem. Let's read the problem. Pam has 20 flowers to plant in her garden. She wants to put the same number of flowers in each row. If Pam has 4 rows, how many flowers should she plant in each row? The student underlined the label in the question sentence, which was flowers. The student identified that there is not any relevant information because we have flowers and the number of rows the flowers are going into, so we need all of our numbers. For name the problem type, the student correctly identified this as an equal groups problem. The student wrote the equation GR times N is the same as P. The student identified 20 as the product, which is the total number of flowers in the garden. The student identified that there were 4 rows. We don't know how many flowers are going into each row, so they put an X under the number of N, which is the number in each group. And then they solve. 4 times what gives us 20? 4 times 5 gives us 20. So I have my number and label answer, 5 flowers. The third type of problem, equal groups problem that students encounter are what we like to call area problems. We've talked about equal groups problems where the product is missing. We've talked about equal groups problem where the number in each group is missing. And now we're going to look at an area problem. So now we're going to look at an equal groups problem, which is an area problem. So the first thing I need to do when I see a word problem is check for a table or a graph. I don't see a table or a graph, but I see a picture here. And I see a picture of a rectangle, and it says 1 centimeter. So I know in my head that I'm probably going to need this picture to solve my problem. But I don't have a table or a graph to number, so I'm going to run through my problem. So I'm going to write R-U-N. The R stands for read the problem, so let's go ahead and read it. It says, Felicia started placing tiles inside a rectangle, as shown in the diagram. Each square tile has a side length of 1 centimeter. She continues placing square tiles without any overlaps to cover the rectangle. What is the area of the rectangle in square centimeters? So I read the problem. The U stands for underline the label and cross out irrelevant information. I find the label in my question sentence. It says, what is the area of the rectangle in square centimeters? The question is asking us about area, but we don't label our answer as 5 area. We label it as measurement. Here we know that we're talking about centimeters, and if it's an area, it's talking about square centimeters. So I'm going to underline square centimeters as my complete label. Now what we need to do is check the numbers in the picture here and in our word problem to make sure they're all talking about centimeters. Here I see this number and it's about centimeters, and here I see this number down here and it's about centimeters. So I've underlined the label and there is no irrelevant information. The next thing I need to do is name the problem type. I need to ask myself, are we putting parts together for a total? Are we comparing two amounts for a difference? Do we have a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? We teach our students that when they find the area, they're really solving an equal groups problem. In area, students multiply the length times the width. What they're really doing is multiplying the groups times the number in each group. So because this question asks us about area, I'm going to go ahead and write EG right here to remind myself that this is an equal groups problem. I've named the problem type. Now I can follow my equal groups schema poster to help me solve this problem. The first step is to write the equal groups equation. So I'm going to write GR times N is the same as P. GR stands for the groups, N stands for the number in each group, and P stands for the product. When I look here, I see that there are groups. When I see groups, I'm thinking about the rows. 1, 2, 3, 4. I'm going to say there are 4 groups. Now there's nothing to cross out because all of our numbers are in this picture right here. The next thing I need to do, let me back up, the product. When it asks us to find the area, that means that it's asking me to find the product. I don't know the product, so I should have put an X right here for step 2. Step 3 was to find the GR and the N. I know that there are 4 groups because I count 1, 2, 3, 4. To figure out how many are in each group, I'm going to count this row right here. 1, 2, 3, 4, 5, 6, 7. Now because we're multiplying, it doesn't really matter if the 7 or 4 comes first. But what we want to teach students is that they're counting up and down and then across, or vice versa, across and then up and down, to identify the groups and the number in each group. Step 4 is to write the signs. I'm going to write a times and same as sign. And now I'm going to find X. I'm going to draw a line to separate my sides to remind me to balance them. I'm going to circle the X to remind me to isolate the X. Here, the X is already isolated, so all I need to do is multiply. 4 times 7 is 28. So I'm going to write X is the same as 28. I have a number answer, but I'm not finished. I still need a label. My number answer is 28. My label, I can look to see what I underline. It says square centimeters. I'm going to write cm squared. Now I know my answer makes sense because in an equal groups problem, the product is always greater than both of the numbers. Here, 28 is greater than 4 and 7, so I know my answer makes sense. We teach students that when they're solving a problem about area, they're finding the length and the width. That's really the same as finding the groups and the number in each group. So whenever students are asked to find the area of a figure, we tell them that they're solving an equal groups problem. Now I'm going to take a second to erase this, and then I'm going to show you an example of a student solving an equal groups problem where the student was asked to find the area. So we'll look at that student work next. So here's an example of an equal groups problem where the student was asked to find the area. Let's take a look. The student put RUN to run through the problem. Let's go ahead and read it. It says a model of a rectangular bulletin board is shown. The top row has been divided into squares of equal size. The rest of the model will also be divided into squares of the same size. What is the area in square units represented by the model? The student underlined the label as square units. The student correctly identified this problem as an equal groups problem because the question is asking us about area. Whenever there's a question asking us about area, we automatically know it's an equal groups problem. So then the student wrote the equal groups equation. GR times N is the same as P. The student identified it's asking us about the area, so we're going to put an X under the P. The student identified the groups as the number of rows. The student counted 1, 2, 3. The student identified the number in each group or the number across as 5, so they put the 5 here. Again, it doesn't matter if the 5 comes first or second. The student wrote the times in the same as sign, and the student correctly multiplied for a correct number and label answer. Now, another thing we teach students is that if they want to, they can continue drawing these lines down to complete this rectangular bulletin board, and then they can count the number of squares as a way to check their answer. Now we're going to show you a video of a student working with a teacher. In this video, you will see the student solving an equal groups problem. As you watch the video, pay careful attention to the fact that the student uses the run attack strategy. The student correctly identifies the problem as an equal groups problem. The student incorporates gesturing. The student writes the equal groups equation, finds P, finds the GR and the N, and correctly solves the problem, writes a number and label answer, and checks to see that the answer makes sense. So as you watch the video, be aware of all of these components.
Could you talk to the class about how you solved this problem A? And go step by step, just like you did.
So first I looked for a graph or a table, and we do have one. So then I numbered all of them. Then next I ran through it and I read the problem. Then I underlined the label, which was red cars. Then I checked for irrelevant information, and I only need the red, so I circled red and crossed out black, white, blue, and gray. So now I named the problem type, which was equal groups. So I wrote GR times N is the same as P. And P was X, N was 5, and the groups was 3. So I knew that. So then I isolated X, and X was happy, so I didn't need to do anything. So 5 times 3 would be 15, which I knew from mental math. So I did X is the same as 15 red cars.
Thank you so much for taking the time to watch today's video, which featured equal groups problems. Equal groups problems are located in our Pirate Math Equation Quest intervention, in our small group intervention, and our 3rd grade test prep STAR intervention. I would like to take this opportunity to thank IES, the University of Texas at Austin, and the Meadows Center for Preventing Educational Risk. Without their support, this work would not be possible. Thank you so much for watching.